In this video, we are going to do 3 examples of 2 sample t-tests. Now, how we know that this is a t-test is that we will not be given the population's standard deviation. Also, our sample sizes will be smaller than 30 even if we add them together. So here we have the average amount of time boys and girls aged between 7 and 11 played sports each day, and it's believed to be the same. Oh, so that wording, that believed to be the same, that sounds like a null hypothesis to me. So it's very important to talk about these null hypotheses. The null hypothesis back in the last chapter was dealing with just one average, and we were comparing that average versus what was expected. So usually it was a mu equals something. But in this case, let's read this sentence again. The average amount of time boys and girls spend playing sports each day is believed to be the same. So that means the population of boys, which I will put mu sub b, and you can use a subscript of 1 if you'd like to for boys or girls. And then mu sub g is believed to be the same. Okay, so that's your null hypothesis right there. Now, your alternative is basically going to be whether you want to claim that girls were greater than boys were greater than girls, or it's just that they're not the same. So let's continue on. So the results, after studies done and data is collected, the results are given. Now, step 0 is usually given to us for organizing things into a table, but for this example and the next one, the tables, just for this example, the table is already given to us. The third example has the table. So what we're going to also do now is just check to see anything else. Okay, it says each population has normal distribution. That's incredibly important for step 2. And then it says down here, is there a difference between the mean of boys and girls ages 7 to 11 played sports each day? Wow, okay, there's our alternative. See, our alternative is right there in that, is there a difference? So that means my mu sub b is not equal to mu sub g. Okay, so the two-tailed test is given. So the alpha is our 5%, so 0.05 is what we're going to compare our p-value to, or the percent chance of us landing in with this data here. So let's go on to step 2. Now what was nice is that earlier in the problem it stated that the population had a normal distribution. So the first thing I want to check in step 2 is to check out my sample sizes, n1 plus n2, and check to see what they equal to, okay? And see if they're under 30, we run the t-test and look for outliers if we are not sure that this is from a normal distribution. And if it's greater than or equal to 30, then we run a z-test. Well, you can see that 9 plus 16, okay, the 16 boys and the 9 girls is definitely less than 30. So then we would normally do an outlier check. Well, we don't have to worry about the outlier this time because it's stated in the problem that there was a normal distribution. So no outlier check. No outlier check because we have normal distribution. And that was given to us in the problem. All right, you're going to see that most of our problems are going to say that they're taken from a normal distribution. Okay, step 3 and step 4. This is where we go to the technology and we let the technology do the work for us here, because the problem itself, if you want to take a look at those formulas, they can get pretty complicated. So we're going to do the 2 sample t-test in our calculator, and I'll show you where that is, okay? We are also, after we look at the 2 sample t-test, we're going to choose the stats in that menu, because we're not, in this video, going to just use the raw data. We're going to be given the stats summarized in the problem. When we get done typing all this in, We will then get our our t value and our p value, draw a picture in step 4, and make a conclusion in step 5 to finish our first of 3 problems here. So we get to our calculator and we're going to click on the stat button and we're going to move over to tests. Once we move over to the test menu, you see that there is a 2-sample t-test. On my calculator, it's option number 4. Now once you hit enter, it will allow you to use the raw data in your calculator lists, but we're going to click on stats. Since we didn't enter the raw data, we were given a table. So what we do is we go back up to our table and we enter in the average for our first group, which we put as our boys. So that is going to be 3.2. For a two-tailed test, it doesn't matter which group goes first and which group goes second. Then what we have is our standard deviation of that group, which was 1. Okay, then we look at our sample size of that group, which is 16. Now we do the average of our second group, which were the girls, and that was a 2. Standard deviation of that second group was 0.866, or 866 thousandths, and the sample size is 9. Now we have to ask, is our mu1 not equal to mu2, or less than or greater than mu sub 2? Well, you can see that our alternative hypothesis is not equal to, so we'll just keep that right there by clicking enter and moving the answer down. Now we're not going to choose yes on pooled here because this does not come from these two groups do not have the same variance. It's easy to note that the pooled option will be no for the remainder of this unit, so we don't need to adjust that at all. Now, the book will probably want you to calculate and then draw, but I like just to cut to the chase, and let's look at that beautiful t-curve. This is what I love about doing this on the calculator. It takes into account all of the size of our work here and makes a beautiful curve. Now, what you're noticing is that you're not seeing any shaded zone, but there is a shaded zone. It's just that the calculator's resolution is too low to print it. So you might be wondering, okay, my t value given in the problem was 3.014. And my p value given in the problem was 0.0054. But all I saw was this beautiful t-curve, and I'm going to put a 0 in the middle for 0 standard deviations away from the norm, but I didn't see anything shaded. But there actually was something shaded. In fact, you're planting your flag at 3.014 standard deviations away from the norm, and that was the part that was shaded. In fact, if you look at the calculator again, it was these pixels at the way end. But the trouble is that the graphic calculator's resolution isn't, didn't really zoom in big enough to see the shaded zone. Now there is also, in a two-tail test, a shaded zone on the other side, because two-tail means left or right. If I put the girls as group 1 and the boys as group 2, my test value would be negative 3.014. So if you find yourself on your XYZ homework on a two-tail test and you have a negative test value and the answer wanted a positive test value, it just looks like you flip-flopped your mu's. You called one group group 1 and the other group 2, where the book chose its way for you. So be very careful if you're doing online homework that you pay attention to the ordering of their group 1 and group 2. So, is 3 standard deviations away from the norm a rare event? And the answer is absolutely yes, because there is less than a 1% chance of landing in either of these two zones. It's really unlikely. So that means if we compare our p versus the alpha, and the alpha in the problem was 5%, this 0.0054, which is a little bit more than 0.5%, is still way less than 5%. And since the 0.5% is less than 5%, this is when we reject. So the sentence I need, it will go like this. be sure to write your inequality, since the p is less than alpha. We have, not will, sorry, we have sufficient evidence to reject the null hypothesis. All right. And that kind of makes sense. I mean, it definitely looked like the two groups did not have similar averages. Even though their standard deviations were somewhat close, those averages were not that close. So we definitely have sufficient evidence to reject the null hypothesis that the boys and girls in this sample group played the same. Okay, moving on to problem 2. Now this is when we're going to need our step 0. And the reason why is because this is not given in some nice table format like the first and third examples are. A study is done by a community group in 2 neighboring colleges to determine which one graduates students with more math classes. So College A, so immediately I'm going to kind of make a little table here. College A samples 11 graduates, okay, n equals 11. And their average is 4 math class. So that's this is A, this is X bar A is equal to 4. With the standard deviation or give or take are 1.5 math classes. So there is my capital letter S of A. Okay. And this is going to be 1.5. College B, okay, here's B, samples 9 graduates. So already I feel like this is going to be the t-test because 11 plus 9 is less than 20. And their average is 3.5 math classes. Okay, 3.5. With a standard deviation of 1 math class. Okay, there's our standard deviation of B. This is why it's nice to have the step 0, just so you can organize everything when you type it in. The community group believes that a student who graduates from College A has taken more math classes on average. So that means our alternative hypothesis, our H sub A, which also you can write as H sub 1, I think it can be a little confusing. Let's do H sub 1 just because H sub A might get confused with group A over here. So this is our alternative hypothesis, is that if you go on average to College A, you would be greater than going on average to College B. Okay. Now, our null hypothesis, and again, 90% of the time you can just say the average of A is equal to the average of B. But I would also accept, if you're doing the paper pencil test here, less than or equal to, because that would be possibly the null in this case, or equal just kind of covers your bases. Because remember, the null hypothesis is the person who's saying, no, nothing's weird happening, and so that kind of fits. Now, it says the second and third sentence from the end of the paragraph, both populations have a normal distribution tested at a 1% significance level. Well, there's your alpha at 0.01. And now it's a very small alpha. I mean, we would have to witness a very rare event for us to throw out our null hypothesis that these colleges are both the same in terms of graduating math students who have taken a certain number of math courses. Now, it says both populations have normal distribution. Well, here's my n sub 1 plus n sub 2. Is it less than 30? And the answer there is 11 plus 9 is less than 30. So we'd have to normally check for outliers, but we're not going to check for outliers because it says assume normality or assume normal distribution from the problem. And since we can assume the normal distribution, there is no outlier check, which is great. Don't have to check for any outliers. Okay, on to steps 3, 4, and 5. Steps 3, 4, and 5 are the calculator steps, writing down your test and your p-value, drawing the picture, and then evaluating what you should do. So let's get our graphing calculator out again. Wake it up. Let's go click on the stat and move over to the tests menu. Go back down to 2-sample t-test, and the 2-sample t-test is option 4 on my calculator. We're using the stats given in the problem. So the average of the first college was 4, with a standard deviation of 1.5. The sample size of that first college was 11. The average of the second college was 3.5. Only a little lower. Standard deviation was 1. And the sample size was 9. Okay, then we move on to what kind of test was it? And from the problem, it was greater than, because our mu sub 1 in front of the colon is greater than mu sub 2. Okay, or mu sub A in this case is greater than mu sub B. So we click enter on that. We're not pooling our data, and I'd like to go to draw just because this does what we need it to do. It gives us our test value, it will give us our p-value, and oh look, a wonderful picture to draw. So keep your calculator in front of you as you copy these down. Step 3's t-value was 0.8899. Our p-value was 0.1928. Here we have our beautiful t-curve, done correctly with our sample size. We're going to plant our flag at 0.8899 standard deviations away from the norm. Now let's remember back to our discussion about standard deviations in the norm, or standard deviations away from 0. We learned back in the past that if we have a standard deviation, give or take 1 standard deviation above and below the norm, this is considered normal. Anything inside of 1 standard deviation above and below the norm is normal. So 0.8899 is considered normal. So I'm not thinking we're seeing a rare event. I mean, you literally almost had a 20% chance of landing inside of this shaded area. So therefore, if we're comparing our p-value versus our alpha, which is incredibly low, 1%, our p-value was almost 20%. Therefore, the p-value is greater than alpha. Do not reject. So if we scroll on down to step 5, we can now put our inequality in. Since we need our inequality, p is greater than alpha, we do not have sufficient evidence to reject the null hypothesis. So we have our inequality, and we say do not reject in a very statistical way. And that is that. I guess you can go to either college if you want to get the a not significantly different number of math classes from each other. Okay, so for this third problem, we are going to compare some large farms in these 2 counties in Pennsylvania. So Indiana County has 8 farms with an average of 191 acres, give or take 38 acres. And in Greene County, they have 10 farms with that average about 199 acres per farm, give or take 12. At a 5% level of significance, can it be concluded that Greene County's farms are bigger than Indiana County's farms? So let's go and test this out. Now, step 0 is not needed here because everything's kind of given to us in a table-like format. Step 1, we can basically look at this sentence here at a 5% alpha. Can it be concluded that Greene County's farms are bigger than Indiana County's farms? So this sets up our null and alternative hypothesis. So here's our null, and our null hypothesis is going to be that the average of Indiana is the same as the average of Greene County. Now you see they are close, but their standard deviations tell a different story. And the alternative hypothesis is going to be that we have Indiana versus green. Well, looks like this is actually saying, can it be concluded that green is bigger than Indiana? So the less than symbol is used right here. Okay, so on to step 2. Now, thankfully in the problem, we can assume normal distribution. So our sample size of 1 plus the sample size of 2 is less than 30. And let's verify that so we don't have to use the z-test here. So we have a sample size of 8 plus a sample size of 10. That's definitely less than 30. So we could run the outlier check if we needed to, but there's no outlier check. Hooray! No outlier check, which means we're on to step 3, which means we get our graphing calculator out. We're going to type in our data, and even better, we can let it draw the picture with us. So with our graphing calculator, we're going to click the Stat button. We're going to click the Tests menu. Scroll on down to your option for the 2-sample t-test, which is option 4 on my calculator, and make sure you're in the Stats screen, because we're going to enter the statistics. In the video after this one, we're going to show you how to enter the raw data into list 1 and list 2 and get your information. So our average of the first group was 191. The standard deviation of that group was 38, and the sample size was 8. It's very kind that the table was given to us exactly in the same order that the calculator needs it. So 199 for the average here, 12 for the standard deviation, and the sample size is 10. Scroll down again. Now, according to our work here, we're going to have less than. Okay, so we have less than there. And we're going to click one more down to not pooled, and one more down to draw, and click on draw. And it draws a beautiful curve, like so. Okay, so let's copy down the t-value, the p-value, and let's see if there was a rare event to see if we have to reject the null hypothesis. Well, our t-value here was negative 0.573, and our p-value is 0.2911. Let's make our t-curve here with 0 in the middle for 0 standard deviations away from the norm, or 0 standard deviations away from no difference. And now we have a really big shaded section here. This really big shaded section has a flag planted at negative 0.573 standard deviations away from the norm. And as we've talked about earlier in this video, if you're within 1 standard deviation above or below the norm, you're considered pretty normal, so this p is definitely not a rare event. The p-value is 29%. You had a 29% chance of getting this to landing inside of this shaded region. And since your chance of getting this value is greater than making a mistake, we're going to not reject the null hypothesis. Okay? So this is greater. Do not reject. So since the p-value is greater than alpha, we do not have sufficient evidence to reject the null hypothesis. All right, well, thank you for watching this first video, the second video actually in this series, but the first video covering examples of t-distributions with 2 samples. Now, in the next video, we're going to deal with raw data of this same kind of problem. Thank you for watching.